Well, good afternoon, everyone. Welcome back to my channel, and this is me, Chanakya Shukla. Welcome all of you in this video. And what I'm going to talk about today, that I was getting so many comments. First of all, let me share my screen without wasting any time. So I was getting so many comments on this particular video, how to make automatic plant watering system using Arduino Uno and soil sensor. So I was looking for a couple of projects out there on YouTube also, so I find this video, and yeah, I did comment one thing here on that good one, but I made some changes in the code and in the system. I replaced the pins and recorded. So this was the whole message which I dropped here, and I got like 3-4 replies to it, that they are asking me the code. So yeah, I can share the code, and here he has also shared the code, but what changes I have done. So let me go through it clearly once again, because I'm making a video specifically for this thing, and I'm going to upload a code somewhere from where every one of you can download it and make it. So yeah, this is the questions, right? So what I'm going to do now, first of all, let me tell you that what all you would need to make this project, because it's a DIY, it's open source, so everybody can make it, and which is a good thing. But all hardware you would need, code, so I will tell you that what you have to code, but what all you will need. So I'm going to tell you. First of all, you will need a microcontroller like this one, Arduino Uno, and yeah, right, it's quite this big, like size of a credit card or some debit card, like a card size microcontroller. And it is quite good, because there are so many easier way to make connections on it. So I first of all, I would recommend to have this when you are getting started with microcontrollers. So this is what I would recommend to start with, microcontrollers. Later on, if you get good with microcontrollers, then you can switch to Arduino Nano, which is this much small size. Even if it is this much, then the Arduino Nano is 1/9 of this size. And there's one more alternate to Arduino Nano, which is this latest thing came out, and I would recommend having this instead of Arduino Nano. It is a Raspberry Pi Pico. It is also a microcontroller, but and you can use the Arduino code on this one as well by using a few what do you say, interfaces, programming interfaces, and you can transfer your Arduino code into this, and this requires MicroPython, and instead of coding in MicroPython, you can use your Arduino code and you can put your codes on this one. It has more terminals, and it is faster, much faster clock speed than Arduino Nano. It is quite expensive also than Arduino Nano, but this is more stable, I would say. It is because you have a lot of copies of Arduino Nano nowadays, because it's an older microcontroller, but this got launched in 2020 or 21, I guess. And yeah, it was launched in 2020. I hope you can see this. Can you see this? Raspberry Pi Pico 2020. Now you can see, I guess, right? You can see now here, right? So it's a genuine original branded. It's not a fake copy. It's the genuine from the company, Raspberry Pi, with the logo itself. It's a logo and it's the thing, and there's a very tiny QR code also behind this. See, there's a QR code, so that you can use this on your sensitive projects, because you cannot rely on those Chinese chips. Sorry to say, but you cannot rely on those chips. These chips I would recommend, even if your functionality is very little. You may overkill your projects by using these, but I would highly recommend these because these are more stable microcontrollers. Yeah, so moving forward, enough of marketing Raspberry Pi. So either this or this, and these are microcontrollers. Then what I would recommend for your automatic watering project, you would need a DC motor like this, which is very cheaply available, around $100 or somewhere. You can find it online also, and you can get it from Lajpat Rai market or whatever, wherever your electronic market is. So this is a DC motor. It can run from 9 volts to 12 volts, and don't use more than 12 volts. These may get harmed with that. So even 5 volts can run these pretty well. Moving forward, you would need one, soil moisture sensor. So I'm going to open it for you guys. I had one bag seal. So what you get in this kit, it's a very commonly, though it is a Chinese product, but it solves the purpose, because basically these are two terminals, and they detect the moisture. When there is a conductivity between, that means the soil is moist, and when there is no conductivity, that means the soil is dry. So accordingly it gives the signals to the microcontroller. Now what you have to do, this is the this is called jumper wire strips, and you just pull out 2 and 3 differently. Use 2 for this, make connections like this, right, and other 2 to this. There is a regulator they have given along with this. So this is a small potentiometer. You can insert some small screwdriver to adjust the sensitivity of your soil moisture sensor. So we will connect it here on the 2-pin side, right, and on the other side there are 4 pins. So we basically need 3 pins, right? So 4 pins are like, I can read it for you. It is VCC, ground, DO and AO. So VCC, I'm not sure you can see it or not. It's just my computer's webcam. I'm not sure you guys will be able to see where it is making focus or how clearly you can see it. I don't think so that you will be able to see. No, but let me spell it out. VCC is for 5 volts, and then ground is for ground, and DO and AO are digital output and analog output. So if you want digital output, you can have digital output, and if you want analog output, you can have analog output. But for this, we will be using analog output, right? Why? Because we don't want ones and zero. We don't want key, is there water or not? We want to know how much water and how much water is not there, right? I hope I'm not wrong. Let me correct myself. So either way you can do. Yeah, wait, let me tell you. So either you give digital signals, even you take DO and adjust the sensitivity from this potentiometer. Otherwise, what you can do, you can simply use the analog output, and then in the coding you use the analog pin. Getting my point? So one way will be digital and one way will be analog. Getting my point? Let me clear it again. That either you adjust the analog input sensitivity by manually adjusting the sensitivity by using this potentiometer, like it is a, right? You can use anything, like even see it is moving. Yeah, it moves, right? So you can adjust the sensitivity with this. It's a small part, so that's how you do it, right? So this is how you can adjust the sensitivity of the soil, and for that, for each plant requires a different moisture for the soil, and you can adjust it with this. And on other side, what you can do, and then you take the digital input that now it reaches the threshold, and give the turn on signal to other pin, and or turn off signal to the other pin. Or what you can do, then you have to make more effort in coding. So it's better we have this potentiometer, this regulator here, right? It's kind of a regulator itself, like you have on the ceiling fan, right? Okay, moving forward. So this is the soil moisture sensor, the sensor, the regulator with the potentiometer, and 3 pins on the end side. 3 pins will be like VCC, like 5 volts, ground, and third is the signal, which can be either digital or analog, right? Now in the that video, Lagan, Lagan. In Lagan's video, we have seen that he was using a relay module like this, right? So you can get this kind of relay module also online or in the open market. So with this, you can, instead of just this small motor, you can use a bigger motor as well with this, because it's just a switch. You give the lower high signal to this, and it can switch on and off any appliance with a higher voltage, right? So it's a relay module. This is a relay. It's a relay module, or we can call it a relay switch as well, right? It has 3 pins, VCC, ground, and in. So it gets, when it gets a low signal, it turns on, and when it gets a high signal, it turns off. So you can adjust your code accordingly. So Lagan was using this relay code. So it was because I was not using this relay code, I was using this motor directly. So actually this relay code actually requires inverse signals. So when there's a low signal, it turns on. When there's a high signal, it turns off. And but for a direct connection, when there's a high signal, it gives a 5 volt to the motor. When there's no signal, so it will be like off. So that signal actually works like a current, while that's how I was using it. And I can show one video where I was using it after my explanation, what the things you will need. Then last but not the least, to run all this, you would need power supply. And for that, in a video which I'm going to show, I was using a power bank, a battery bank, whatever you call it. But if you want to give it a direct AC supply, but make sure your because it's a project which requires safety with the water, so make sure your connections are water safe. You can use a glue gun or whatever you do, just keep it safe from water, because now what I'm going to tell you, you will be using high voltages like 220 volts, which you get the supply from house, or maybe use an inverter or whatever. So this is a what do you call it? It's kind of a transformer, step down transformer, in which you actually turn 220 volts to just 5 volts, which is sufficient to run a microcontroller, maybe this one or either this one, right? So you can get it online as well. On this side, you can directly connect it with the power supply of your mains, 5 amperes obviously, and on the other side you will get 5 volts DC, constant, stable. And look at this. So this is a small transistor, then there's a capacitors, and there's some more transistors used inside it. just to give the stable 5 volt supply on the other side. So I've used these supplies, and I guess they are very stable and works fine, right? So you can use these in your projects if you don't want to use batteries, because battery will die in a day if you want to use it on a plant. So I've tried using those 9 volt batteries, they die in a day. I've tried using bigger batteries, they die in a week or so. So because when you're going to use these on your plants, so you will need like 24/7 power backup. So how are you going to do it? And you cannot even do it with a solar panel or something, because sometimes there's sunlight, sometimes there's no sunlight. So I would recommend using these, but try to make it waterproof. Yeah, and for waterproofing you should consult some more videos or some expertise, because it's a different area. I'm just going to tell you how to make a project, right? And obviously make safe connections, because you're dealing with electricity. You should need proper guidance with experienced people, right? So moving forward, now we know what all we would need. Obviously you will need a plant also to try it out. All right, so yeah, now moving forward to the coding, right? So without wasting any time, let's go back to our screen. And so all of this, guys, I'm going to give a shout out first. Nerfi, could you tell me connection, as you are saying I'm interested to do this project? Sure, I will do. Can you please provide the code? I will. Can you please give the code? Please. Oh my god. Joya Chakraborty. Yeah. So sure, I will. And Aaron self. Sure, I will provide the code. And Shivani Dubey says, can you please provide code? Yeah. So all of you guys, thanks for appreciating my effort. And now I'm going to share the code, because parallelly from this video, though this video was like a year ago, and maybe parallelly I was also working on a project. So see, in this video itself, Lagan has used a relay, and then he gave supply to the DC motor, right? So instead of giving supply to DC motor separately, you can either use it directly, because you don't need too much pressure to water the soil's roots, right? You don't need pressure, so you don't need 9 volts or 12 volts to give this water. Even 5 volts or basic 5 volts which you get directly from the Arduino, that can be good. I've used it, that's why I'm saying. I can show you in the video itself, right? So you can use relay to power up a bigger motor, right? Like if you are in a field or something, there you can use it. And but obviously you're dealing with water, so make safe connections. I am just repeating again and again, because water and electricity are not good friends, so don't do it. So here this guy has done a great job. He's using a jar. I've also used a jar like this, and yeah. So let me just go through my comment again, because I want to cover everything which I've said in this video. So I replaced the pins and recorded them for the Arduino Nano. So yeah, I'm going to show the connections for the Arduino Nano, because Arduino Nano and Uno have different pins, right? Some pin settings are different, PWM pins are different, and number of pins are less in Nano, so we are going to code accordingly. And Arduino Nano is getting popular these days. Not everybody is going to get a Uno. Like even for a copy, you will get this one more expensive than a Nano. So even if you go to a retailer shop, they will recommend you getting a Nano, Arduino Nano. So I'm going to, and it's a smaller project. You'll get So that's a better option. Okay, then I said I found that when the sensor was giving a low signal, the relay motor went off. Yeah, so relays sometimes give opposite signals, so you can alter, so which I have altered. And even if you buy some relay, I'm repeating it again, so maybe some relays they turn off at high signal and vice versa. So tweak the code accordingly, I would say, right? Just try to use a low instead of high, high instead of low. Okay, so moving forward, that makes no logical practical point. When soil is already wet, why would we want more water to be pumped into the soil? Okay, so maybe that code had a different thing, right? So I'm going to, it should be another way around, which means when the soil is found dry. So yeah, just it becomes a opposite code. You can use it. Okay, also I directly connected DC. Using a relay would be overkill. Yeah, that's what I said for a small plant. Yeah, if you're using a bigger motor, a submersible motor, or maybe a bigger tank with a motor, and you're using a bigger wattage motor in a field, then I would recommend using a relay. Otherwise, for a small DC motor, you can run it directly from a microcontroller. Relay can be useful if I want to trigger a high voltage bigger AC motor with the same system. Yeah, correct. To maybe water a whole garden, a park, or a field of crops. That's correct. But very useful watching you in the video encouraged me to finish a project I was working on for more than 6 years from now. Yeah, I was. Thanks a lot. I made a video too, not a tutorial, but now I'm going to show what I did in the code. So you can, I'm going to upload it in front of you guys on my GitHub account, right? So you can download it from there. I have a couple of more codes uploaded here, so you guys can check it out, right? So this is the code, right? I've saved it somewhere for you guys, right? This is the Arduino IDE, and you have to install it in your computer systems, whatever OS you are using. Now what you have to do, so I made an integer named water, and then what I did, it's a variable, and then I made a void setup. Then on pin 13, even on Arduino Nano, is for the LED, and LED, and there's a socket also. It's a digital pin on Uno also. So pin 13, we made the output pin for relay board. This will send signal to the relay. Okay, so you can connect it with the relay, or you can connect it directly. So I'm writing it, or you can connect it directly with the DC motor, right? Then pin 12, input pin coming from soil sensor. So we are using 2 pins, right? Pin number 12 and 13. So these pins are very common even in Uno and also in Nano, right? Now moving forward in the code, so then I made a void loop in which water is equal to digital read. So this variable which we have created, it will read from pin number 12. So reading the coming signal from the soil sensor, yeah, and we will write it in the coming signal, coming digital, because we will be using DO in the soil moisture sensors. Okay. So we will connect it to DO, right? This is the code for that. DO. DO means digital output pin, right? I'm writing it clearly for you guys. Then if water, okay. So this variable, when it gets a low signal from digital pin 12, then what it should do, if water level is full, then cut the relay. Yeah, then cut the relay means then it will cut the relay, and digital write 13 will become low. So it will give a low signal to pin number 13. Okay, low is the cut the relay, is to cut the relay. Yeah, and also to turn off DC motor, right? Okay, because in Arduino the small currents are signals, right? So even 5 volts or 3 volts or 3.3 something kind of volts are signals. So DC motor will run with this much small voltage, and it is enough to pump the water. If there is not too much work to do for motor, like if the motor has to fetch the water from a lower level to too much high, then also you would need much voltage. Otherwise, if you keep this keep this in a tank in a same level, then it can supply the water automatically without the need of too much of voltage. So that's the trick. That's my trick. So okay, digital write 13 low. Low is to cut the relay. It will cut the relay also, and also to turn off the DC motor, right? And else digital write 13 high to continue providing signal, and water supply, and keeps the DC motor running. Okay, all right, simple code, simple logic. And then to this process I have given a delay of like this is 400, I would say make it a second. So to make it a second, this 1000 is called a second. All right, like putting this 1000 according to the clock speed of the Arduino, this 1000 is 1 second. All right, so 2000 would be correct 2 seconds, right? So further I made some more notes, and thanks. Code is modified by Chanakya Shukla on what's date today, 2 November 2023 at say 14:35. All right, so now I'm going to save it also, and I'm going to copy this code and put it, and I'm going to put it on my GitHub profile. All right, so it's been long that I haven't uploaded here anything, so I have forgotten how to do it, but let's do it. Create new repository, import repository. So I'm going to create a new repository, and we will name it what we have named it here, automatic plant watering system for Nano. Automatic plant watering system, good name. Automatic plant watering system for Arduino Nano. Cool. The code is for Arduino Nano microcontroller to set up an automatic plant watering system. Cool. Public. Add a readme file. I don't think so. I've added notes to the code, so that's self-explanatory. License is like what I'm going to use here, what I've used before. So I'm using this Creative Commons because I'm sharing it in the open, right? Let it be. Creative Commons is okay. And just create it. Okay, now add file, create new file. I'm going to add the code here. Right, so guys, here is the code. Okay, I guess I'm not missing out anything. Int water, you simply just paste it and thank me later. Alright, name of your repository, name of your file, so it is the, what is the file? File is the same thing. Code. Fine, seems anyone is checked it that it code is fine. Commit changes. Wait. Commit message. Create. What create? Wait. Is it asking for anything else? No. Commit changes. Commit message. Create code. No. Extended description. The code is for automatic plant watering system setup. Please please change low command to high and vice versa. That's how you write it. If necessary, you change low command to high and vice versa if necessary, according to your relay module build variant. Alright, below, I guess this is, I have explained well. I don't want you guys to like curse me for this, you know, because I'm not trying to harm anyone. I'm just trying to help those people like who are very curious to know. So please change the low command to high and vice versa if necessary according to your relay modules build variant. Yeah, that's okay. And you can change the delay time where 1000 is equal to 1 second. Unit is equal to 1 second. Okay, cool. And what else? Yeah, this is a simple code. And what shall I read what you need? And I've already told you guys. Commit changes. And this is the code. You guys can find it. Yeah, I can always copy this path copied, and I'm going to share with you guys also this thing. All right. Let's see if it shows in my profile. So now I have like 4 codes, okay, and this is also public. Ooh. This one is the code, okay? Code for Arduino Nano. Just simply click it and copy it and paste it to your Arduino IDE. Alright. Okay. And then obviously if you don't know how to use Arduino IDE, there are several other tutorials like you have to connect your board. Like in the boards you have to choose which board you are using. Then you should be using a correct processor. So if you are using an older board, so because these Arduino softwares are also now updating. So if you're using an older microcontroller, then you would need to use an older software or whatever driver for that. Then you have to select the port also, and then there's several settings for the board also you have to do, right? Then you can check for errors also, like you can check it is very fine. It is compiling the sketch. Here it is loading, and it says that sketch uses 1042 bytes, 3% of program storage space, maximum is 30720 bytes. Global variables use 9 bytes, 0% of dynamic memory, leaving 2039 bytes for local variables. Maximum is, so yeah, there are no errors, otherwise it would have shown errors here. And the code is general and it works fine. And when you connect your board with it, you simply use, instead of verify, you can simply upload. Cool. Now I'm going to save this and close this. And what else I have to do? Code is there, and I'm going to just put it in the description of this video. Cool. So I guess hope you guys enjoyed, and nowadays grow more plants, and if we cannot take care of them, to at least use machines in a good way, better way, so that we can save the environment. So in a way we are saving the environment with this. Don't use batteries, because batteries are actually harmful. So don't use batteries for these projects. Nowadays grids are making clean energies, so why not use it? And this thing, it only takes 5 watts of energy, 5 watts of power. How you can calculate the power? I hope you know that the formula for power in physics, it is voltage multiplied by the current. So it takes 5 volts, and current it takes 1 ampere, so 5 into 1 is 5 watts. So all it takes is 5 watts, and in return you will never get your plants dying because of unscheduled irrigation, right? Yeah, so that's the code. Thank you for encouraging me to make this video, and thanks this guy also. Wait, he has also done a great job. Techie Lagan. So Lagan ji, thank you, and I'm going to share the link in this comment as well. And yeah, that's all for today, guys, and we'll see you guys again. If you're first time coming to my channel, so this is my channel, and we make videos on multiple topics. I keep on sharing very entertaining content, very educating content, and different kind of content here. So do like, share, comment, and I'll see you guys in some another video, right? All right, see you then. Have a good day, and keep learning and keep teaching, and adios. Bye bye.